Welcome to your last lesson of this section. In the last lesson, we finally finished our line detection algorithm and identified lane lines in our image. What we'll do now is use that same algorithm to identify lines in a video. This is the video, and we'll use the algorithm we currently have to detect lane lines in every single frame. This video you can access from the following GitHub link, or you can feel free to just type out the link, it's up to you. Now anyway, once you're on this page, click on test2.mp4 and download it. Alright, and upon downloading it, make sure it says test2.mp4 so as to stay consistent with the videos. And once you download it, wherever you have it downloaded, drag it into your project, Finding Lanes. If you are using the Atom text editor, don't try and open the video with Atom, otherwise it will freeze. Alternatively, we could have placed this video in desktop or some other directory and just referenced its path, but we'll go with this for now just to keep things quick. Regardless, to capture this video in our workspace, we need to create a video capture object by setting a variable name. Cap is equal to cv2.video capture, and we'll capture the video test2.mp4. And while cap.isOpened, this returns true if video capturing has been initialized. We'll enter into a loop where we will first use the read function, cap.read, to decode every video frame, and what this returns is two values which we can unpack. The first value is just a boolean that we're not currently interested in, so leave that as blank. The second value is the image, the frame that's currently being projected in our video. And it's the current frame of our video where we'll be detecting lines. So what we'll do is actually copy and paste the code, the algorithm we already have for detecting lines. We're not going to do it all over again. And wherever it says lane image, we're going to replace that with the current video frame. Over here, here, and here as well. Make sure to get all of them, otherwise your code will not make any sense. Pretty easy. All we did was apply the algorithm we already implemented, but instead of a static image, we're doing it on a video, since we're not working with images anymore. You can go ahead and comment out this code or delete it, it's up to you. I myself will comment it out. And now with imshow, we're still showing the current image that's being processed. As for wait key, if we leave this at wait key 0, you're going to be waiting infinitely between each frame of the video, so your video would just freeze up. Instead, we want to wait 1 millisecond in between frames to then display the next one. Now, before we add any logic to break out of this loop, let's just run the code by going to our terminal and running pythonlanes.py. And alright, it identifies the lines in every single frame of our video. That's pretty cool. And this is nothing new. It follows the exact same process as how we detected lines in the image. We're still applying the Canny algorithm to get the gradient, detecting lines with Huff transform, and then averaging them out. Except now it's being done in every single frame of the video, repeatedly inside of a while loop. That is all for this section. Now just to finish this lesson off, if I rerun the code and try to close the video, it doesn't work. We need a way to actually break out of this for loop and not just wait until the video is complete for it to dismiss. So we'll go back here. Upon pressing a keyboard key, we want the video to close. So we'll put this inside of an if statement such that we're still invoking the wait key function. We mentioned that it waits 1 millisecond in between frames, but what it also does is it returns a 32-bit integer value, which we can compare to the numeric encoding of the keyboard character that we're going to press. The numeric encoding we can obtain from the built-in function ord, and the keyboard character that we're going to press will be Q, and we'll just set a comparison operation between the two. Ultimately, when we press the keyboard button Q, the comparison of these numbers will evaluate to true, and once they are equal, we'll break out of the loop. And once we break out of the loop, we'll close the video file by calling cap.release, and we'll also call cv2.destroy all windows to destroy the window that we're currently on, to close it. Rerun the code, python-lanes.py, press Q, and everything works fine. If the keyboard action did not work out for you, a common trick is to apply a bitwise AND operation with the hexadecimal constants 0xff. Just know that this operation, it masks the integer value we got from wait key to 8 bits. Which ultimately just ensures cross-platform safety when making our comparison. It's still the same concept as earlier, since when we press Q, this comparison still evaluates to true, breaking us out of the loop. Rerunning the code, everything should still work as expected. That is all for this section. We used Canny to convert our color image into a gradient image, and from the gradient image we detected the most relevant lines, averaged out the lines, and then displayed them on the image that's currently being processed. In the near future we'll be using a more advanced technique to detect lanes, but for now this is pretty awesome. Great job on making it this far.